Welcome again to my class. In today's video we shall talk about surds. Now surds is a part of algebra and it's a very important aspect of mathematics. Now what are surds? Surds are numbers left in square roots that are used when detailed accuracy is required. So we use surds for accuracy, and also when surds are written in decimal forms, they go on forever. That means that they don't give exact values. I'll be showing us some examples of surds. For example, root 2 gives us a decimal form which goes on forever. That means that root 2 is a surd. Now root 4 gives us 2, so root 4 gives an exact value, so root 4 is not a surd. Other examples of surds include root 3. As you can see, it gives us a number that goes on forever, so root 3 is a surd. Root 9 gives us 3. Root 9 is not a surd. We have root 5. As you can see again, it goes on forever. Root 5 is a surd. Root 16 gives us 4. It is not a surd. Root 7 is a surd. Root 25 is a surd. It's not a surd. Root 11 is a surd. As you can see, root 2, root 3, root 5, root 7, root 11 are all surds. This means that surds are irrational numbers. Now, I will show us a very important concept in surds, and they are called perfect squares. Now, perfect squares are very important when simplifying surds. Now, what are perfect squares? Perfect squares is a product of two equal integers. For example, we have 3 times 3 is 9. This means that 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5 is 25. That means that 25 is a perfect square. 10 times 10 is 100. That means that 100 is a perfect square. We also have 11 times 11 is 121. That means that 121 is a perfect square. So all these are perfect squares. These are all perfect squares. We have a lot of perfect squares. When two equal integers gives a number, that number becomes a perfect square.